All right, so I'm Mark Olitowski, and we're doing a webinar today on how to build a socially connected Alexa skill from start to finish. So this is going to be one of our first webinars from Sphere of Influence, and we're just kind of do a trial here. We want to see kind of how a presentation goes and how we can kind of quickly demo technologies off and show it to the world. So first off, what is an Alexa skill? So if you've ever used any kind of Amazon devices, any of the new stuff that's come out, they have Amazon Echoes, they have the new Echo Show, they have the Echo Dot, things like that. And Alexa's skills in particular are the voice-enabled applications you can build utilizing the Alexa web service from Amazon. So Alexa's kind of their smart, it's kind of their brains behind a lot of their web service pieces. It involves voice recognition, artificial intelligence, things like that. So Alexa is only supported right now by obviously Alexa-enabled devices, the ones I've listed before. There's also some now.
I'm not sure.
No. And if you say it's a name, it gets triggered off too. So there's also some new phones coming out that have automatic Alexa built into them as well. So it's going to be kind of neat to be able to play around with those in the future also. So when you're building an Alexa skill, there's a couple different types you can build. There's smart home features, which are going to be things for turning on lights, opening a garage door, anything you have to do with a smart home, you can build that into an Alexa skill with some kind of pre-built API pieces they already have. There's also what's called a flash briefing, which is just kind of feeding items from the news, not really interactive pieces at all. They just kind of, you ask it to do something, it's just going to present a bunch of information to you. So in addition to that, they also have a video-based one, which that's only used nowadays with the Echo Show, which is going to be the video device in the bottom left-hand corner of the presentation window. And what that has is, if you want to do anything where you're requesting to play movies or playing music videos, interacting with YouTube, you'll be able to use the show skill for that type. And the last type is a custom. So custom skills, you can kind of do whatever you want with them. You can contact a web service, you can do any kind of custom interaction API stuff, and that's what we're going to be looking at today, because it's just the most versatile. It's the most difficult to implement, but it's also going to give you the most power for what you want to do. So the whole goal of this was kind of to demo the technology of being able to develop an Alexa skill with a custom interaction model. So we're going to talk about interaction models in a bit. But what those involve is kind of the back and forth dialogue and how you interact with the web service from the Alexa API. What we're also going to do is we're going to utilize, so because this is all Amazon based, you have to use a lot of the Amazon web services to be able to host your skill or to be able to interact with pieces of it. Specifically, we're going to be using AWS Lambda, and we're going to talk about that again in a little bit, and that has to do with where the actual skill itself, the code runs for hosting it. We also, Alexa skills, you can use a multitude of languages. We're going to be specifically focusing on a C# based implementation. It's actually one of the more difficult ones because it's not
Sorry, I'm not sure.
Let me turn the Alexa down for right now so it doesn't keep responding. So it's one of the more difficult ones to implement using C# because it's not native to the Amazon system. So doing that kind of gave a little bit more experience in the tooling set to be able to deploy these things out to the Alexa environment. We also want to do is we want to find a way to implement a backend database for storing user data with this. That kind of complicates a little bit because a lot of the Alexa skills are more based on just give it some information, it's going to feed you back a reply, it's going to look up recipes, whatever for you. So we're going to be trying to utilize a database backend for giving a little bit more interactivity between what's going on the app side and then what the user's trying to do. In addition to that, we want to be able to utilize complex dialogues between the skill and the user. So instead of just simply asking it to do something like what's the weather today or what's my shopping list, we want to have a dialogue back and forth. We want to have the user talk to the system talk back, request more information, the user goes back to the system, kind of that back and forth piece there. what we also want to do is a lot of the Alexa skills are kind of based on one-off sessions. So you just tell it to do something, it does it, and then the session ends, and then you do it again. It's kind of a stateless machine. So what we wanted to do is look more at how it would be if it was a stateful. So that's kind of part of the dialogue piece, which is going to be when you feed it some information, it does something, it asks you for more information. You could potentially pause for a little while as well. And if you pause and come back to it, we want it to actually remember the session that you were in, so you're not starting from scratch every time. And the last thing is we want to build a little bit of a social aspect into this. Most Alexa skills are individual user-based. You just need it to do one thing for you, and it does that one thing for you, and that's it. So we want to try to see how it would be if there were multiple users involved, in which at that point you have to deal with user accounts, tracking devices, all those pieces, kind of know what differentiates one person from another, one Alexa device from another. Let's see if we can get the next slide going. There we go. Okay, so for doing our development here, we have a couple of prerequisites. So the prerequisite is that we're going to have to, like I said before, we have to utilize an Amazon Web Service account for hosting a Lambda service in the database. So this kind of assumes you already have a AWS account. So we're not really going to cover the pieces to actually start the implementation of that. Just wanted to make sure that the window was hidden there. And then we're also going to, you have to sign up for a developer portal account, and that's part of the Alexa specific pieces that you're doing. So we want to make sure, part of the prerequisite is that you'll have to already have those pieces in place. Plus, because we're going to be doing a C# implementation, you're going to have to also have Visual Studio already installed, and Alexa itself, the Amazon Web Services for Lambda require .NET Core, so you have to have that tool set. And then we're also going to go ahead and get the AWS toolkit, which is going to simplify a lot of the process, and we'll go over that later. And then lastly, if you want to be able to test on an actual device, you will have to have an Alexa-enabled device. Luckily, this is optional. You can do all your development and all your testing without the device itself. Not sure I keep getting hung up on the PowerPoint here. Okay. So looking at all these pieces that we want to put in place, the kind of things we want to test, I decided just to go with building kind of a small game. Instead of trying to figure out something that would be applicable to using a database, multiple user accounts, social interaction, all those pieces, I figured, if you have a game, most of the time, it's going to be data-driven from a database. You're going to have state sessions. You're going to be storing user data so that you know who you're connected to. So that seemed kind of like the best approach for just kind of doing a quick demo application for this. So what we're going to do is we build something called Treasure House. So Treasure House is kind of like, if you're over the age of 30, you probably know what Zork is. So Zork was a text-based adventure game that, you would type in what you want to do, like you would say you're in front of a dark house, you'd say enter house, then you'd say look around house, things like that. You'd give it basic commands to try to complete your text adventure without any visuals whatsoever. So I pictured that as something of a good initial project to do to kind of see how it would be to take something that was normally text-based no visuals, turn that into a voice-based project no visuals. So the purpose of our small game is going to be just to look around a house and try to pick up the most valuable objects you have before you have to escape. So we're going to do, there's a couple of rules involved in the game, and that is you only get a certain amount of movement points in which you can kind of look around, you can pick up objects, you can inspect objects, and each one of those will take a movement point out from you. And there'll be kind of a maximum weight you can carry. So, if you look around the house and you pick up everything, you're eventually going to load yourself up and you can't carry anymore, and then your game is over. And then for the social side of things, what we're going to do is we're going to have multiple people inside the house at once. So when you join the game, there may already be two or three other people inside the game as well that are all competing to pick up and search around the house as well. So if you're in the same room as somebody else and they pick up an item, when you try to look at that item, it's going to be gone. So it's kind of a race to the finish, and that's kind of our social aspect for things. As a goal, what we'd want to do is do dynamically generated maps. This would be something that, so instead of the game was not exactly the same every time you went into it, we would dynamically change these pieces so that from one session to another, when you went inside the game with other people, the world would be different. The house would be different. There'd be different things in different places, different objects, different descriptions, all that. And finally, what we want to do is, as part of our state-based storage, we want to store the high scores for everybody. So you'd be able to see your personal high scores, community high scores, kind of adds the social aspect, adds the competition piece. So now that we get a little bit into the details here, so the first piece that we do have to do to implement a project like this is we have to look at AWS Lambda. So the reason why we're picking AWS Lambda, it's one of the many options you can do for hosting an Alexa skill. They're fairly versatile with how you host it, but if you want to make it the most simplistic deployment as possible, AWS Lambda is definitely the way to go. What it is it's their serverless computing platform. It's very similar to what Microsoft Azure offers, and that is instead of procuring an entire server, putting all your tool sets on it, deploying your code, doing your certificates, all those pieces, you just basically deploy a chunk of code to it, and it creates an endpoint for you. And then that endpoint can be talked to by an Alexa skill, which will do all your interaction for you without having to do all the extra backend stuff. Like I said, having to not do certificates between the connections from Alexa to the service itself saves a ton of time and difficulty, because if you're hosting your own solution somewhere on a custom web service, you have to deal with those pieces. What it also does is it gives you functional testing and also usage metrics. So you can feed it in, because all the Alexa skills are all driven basically by JSON. And what using Lambda does is it gives you a whole test bed for doing those pieces. So you can trigger off tests for intents, and I'll go over these things later. Tests for intents, you can do tests for shutting down, starting up the service, all without having any kind of device itself at all. So AWS Lambda right now supports Node.js and Python natively inside the console. What that means is that within AWS Lambda itself, you can actually just type your code out in there, assuming you're not contacting any external packages, and you can have a completely self-contained Alexa skill just inside the code inside Lambda without having to use any extra deployment pieces. When you're utilizing Java or C#, then you're going to have to actually deal with deploying the package to the server, and there's also some limitations on versioning. Currently, it only supports .NET Core 1.0 for the C# world, which could pose some problems if you're trying to deploy something from like a newer technology set. But for right now, for what we're doing, it fits the bill. And then, as we'll see in a minute, the AWS toolkit simplifies the process a lot when you're dealing with .NET trying to deploy to these pieces. The next piece we have to deal with after AWS Lambda to host the code itself is the Amazon Developer Portal for actually configuring and building the skill set. So the Amazon Developer Portal allows you to go in there and actually say, okay, well, here's my skill that I want. You can see in the screenshot here, you define what type of skill it is, or if you're using a custom one. Languages, you have application IDs, and then you actually give the invocation name. And that's the name that when you talk to Alexa, you say, Alexa, open this, or you just say the name of it, and then that's what's going to trigger your skill to start launching. And within this, you have all your configuration items for trying to talk to whatever web service you set up. In our instance, because we're using AWS Lambda, it simplifies that process a lot. Within Lambda itself, you get an endpoint ID and endpoint address, and you plug that directly into the Amazon Developer Portal, and that gives you all the pieces you need there. It also includes an additional test interaction model and voice simulator. So Lambda offers one itself for testing your Lambda functions, which may or may not be Alexa pieces. You can kind of do whatever you want with AWS Lambda, but when you're dealing with an Alexa skill specifically, you're going to have an additional interaction model. You can actually use your own voice. You can have it talk back to you all within the website itself, so you don't have to have your device when you're testing your Alexa skill. It also gives you the ability to do any of your beta testing and publishing pieces. So when you're actually ready to deploy to the real world, you can go through and have it certified by Amazon to make sure it's okay for the skill set, for the skill store, and then you can publish it out. You can also beta test on your own devices using this. So once you've registered your own device with the developer portal, then you're able to just instantly deploy to it and be able to test your own skill with it. You can also go through and edit additional features, like if you want to add video or voice, like audio playback to your skill. Any of those pieces all can be configured inside this portal. The most important part of this portal, when you're actually doing development, is the interaction model builder. So when you're dealing with Alexa, it's a little bit different from other mindsets. You don't just, nothing you do when you're talking to it directly goes to the web service. It has to go kind of through what I consider like a Amazon, kind of like an authentication server before it goes back and hits your code in your Lambda function. And what that piece does is it handles taking what you taught when you say to the Alexa device, it takes that piece and turns it into something usable by your function. So you're not dealing with straight audio, obviously. What you want, you know, when you're building an Alexa skill, you want to deal with code. You want to deal with knowing finite types that are coming through, and you want to know what variables they're passing in, and you want to have it just handle all of the audio decoding itself. So that's kind of what the interaction model builder does. So it's a piece that they've implemented, and I'll show you a screenshot after this. So it's the piece they built into the developer portal that allows you to build out your model using either code, just straight up code, which is going to be JSON, or using the model builder GUI itself. Model builder GUI is actually very good. I was kind of surprised. I thought it would be, it's in beta right now. I thought it might be a little bit incomplete, but it actually works out pretty well. And when you start getting into the model builder, you start seeing the different pieces you need. So there's really three main items when you're dealing with the model builder. The first are your intents. So an intent is, it's kind of your main interaction point between the user and the skill itself. So those are the actions. Those are when you talk to Alexa, when you're asking your application to do something, those are your main pieces. So if you're asking it for help, you're asking it to give you a list, any of those things, you build them out as intents, and those are your pieces that are, you kind of think of them as your core functionality. And then intents can have one-to-many slots. So a slot are kind of your variables for those actions. So when you call an intent and you tell it, give me my shopping list. Well, your shopping list is a thing. That can be considered an intent. But you'd say, give me my shopping list for today. Give me my shopping list for tomorrow. Those would be slots. So the actual date you're giving it, the variable you're giving it with your action would be considered a slot variable. And those are something you can define within all of the model builder pieces. And then the slot itself has to have a slot type. So that's kind of the third and final piece when you're dealing with this. And those are all of your valid entries for a particular slot. So if you're saying, give me my shopping list for today, give me my shopping list for tomorrow, you'd actually have to define the slot itself, which would be, let's say, date. And you have to give it all possible iterations of what could be inside that slot. Amazon does not let you feed it any kind of random information. It has to be defined pieces. Anything you ask your skill to do has to be predefined within some kind of API, within some kind of, within the interaction model builder, to know what you can possibly do with it beforehand, before it's done. So this is why it's such an important piece, because you really can't interact with it unless those pieces. You can't, you know, if I build a trivia game, I can't ask my trivia game what the weather is. It's not going to have any idea what I'm talking about, and it will actually block that from getting to the app itself because it's not defined within the pieces you're working on. On the plus side, they do give you predefined pieces on these. So if you're looking at slot types and you want to do something related to date, you don't have to go through and define every single possible date out there because it would just take forever and probably be impossible. They give you predefined slot types, which would probably encompass all those dates like yesterday, today, tomorrow, next week, all those pieces. They have things like states, they have things like locations, basic object types. You can use their predefined, or you can just define your own custom one, which is actually what we did in this project because they just didn't really have pre-built slot types or intents or anything like that to do what we're trying to do. So this is kind of just a quick screenshot of the interactive model builder itself. You can see here on the left-hand side, I have an intent, which is called examine, and that's what's selected right now. So those are kind of, examine is one of my pieces of core functionality that you'll see later. And then when you have an intent defined, you have to define the languages associated with talking to that intent. Because I don't just want to have the word examine be the only thing you could say to it. So we have what's called utterances. So the utterances are things you can say that would cause this intent to be triggered. So I have, instead of just examine, it's examine, you can call it investigate, you can call it inspect, you can call it look at, and then the piece that's inside those, the braces there, that's going to be the slot itself. So when you say investigate or inspect or look at, it's expecting the name of an item. So the item is going to be the variable that's going to be passed back to the function. But again, those all have to be defined. And we'll see later how I do the definitions for those. But what we have to do is predefine every possible item you could be passing into that. So I had to, in addition to this piece, define a slot type of item, and then define every potential item you could ever say to it with all of their synonyms to be able to pass into your Alexa app. Again, I'll go over some code later, but this is just kind of a quick screenshot of that. So now that we've kind of dealt with the different pieces on the AWS side, we want to look at what's required on the C# side to build it. I'm currently using Visual Studio 2015. The reason I use 2015, not 2017, there's a bug in the AWS toolkit right now that was causing me a problem. I tried it multiple times, multiple versions. I could not get it to work. It's just crashing on project creation. So I went back to 2015 and that worked perfectly. The big thing in the download, one of the core pieces is the AWS toolkit. So the AWS toolkit gives you a lot of cool functionality if you're dealing with Amazon Web Services. So first thing it's going to give you is your Lambda packages, and that's the way you define a Lambda function and be able to deploy it out to AWS. So it gives you all the libraries you need predefined for that. It gives you the function format, all those pieces, and that's just done for you. It also gives you the AWS Explorer. So that gives you kind of a quick view and a quick way to deploy and change, configure all the pieces of AWS that you have running in the service right now, all from within Visual Studio. It's a really cool feature. You can update databases, you can delete things, updates, really cool stuff. It's also going to give you a one-click deployment to AWS. That's kind of part of the AWS Explorer, but built in specifically for the Lambda pieces. That allows you to just right-click on your project, say deploy to AWS, gives you a couple quick configuration items, you just send it off and it's up there and it's uploaded instantly. It also gives you another third way of being able to test your endpoint functions. So we've looked at, I've already showed you the two different ways. You can do it from AWS Lambda itself on the website. You can test your function. You can do it from the developer portal. You can also do it from AWS Toolkit within Visual Studio to kind of give even more real-time testing as you're developing these functions. And I said before, you have to use .NET Core 1.0 for AWS right now. That's just a limitation on AWS Lambda. Hopefully they'll start supporting some future stuff, but it's not a big handicap at this point right now. So since we have a database backend, we're utilizing Amazon RDS. So that just gives you any way you can deploy any type of relational database that they support on Amazon right now. We're specifically using Microsoft SQL Server 2016 on our instance. Did that just because the tooling for interacting from C# and .NET to that is a lot easier. So just for a quick project, it was the easiest thing to spin up. And to interact with that, we're using Entity Framework Core 1.0. This is a back version we had to go back to because we're stuck on .NET Core 1.0, so we're kind of pushing back a couple months worth of technology, but it still works. And the last piece we kind of want to be able to build up a skill service is the Amazon.NET NuGet package, or sorry, Alexa.NET NuGet package. What that does is, because everything with Alexa is based on JSON being passed back and forth, so the Amazon service passes you JSON, you deal with it, and then you pass it back JSON, and it gives the speech back to the user and the interaction pieces. Alexa.NET handles that for you. Somebody built this package out to do request response pieces. It works out great, so definitely to speed up development, it's a great tool to use. Here's just a quick screenshot of the AWS toolkit. You can see the AWS Explorer on the left-hand side with all our instances we have up. You can see the endpoint testing here. So I've already uploaded an endpoint at this point. You can kind of see that you can do your sample input testing. You can change the JSON, see what the response that comes back is, configure things. It's got a lot of neat stuff in it. Okay, so at this point, once we've gotten past all those pieces, we have our tool set and all that stuff, we would want to build out the skill service. Obviously, for time constraint, I'm not going to build out a skill service. I will be showing you the code for these pieces right after this, but I just want to give a quick summary of what you kind of need and what the whole. It's actually very simplistic to build out a skill service once you have all those other pieces in place we've already talked about. So to be able to build out within .NET, the first thing you do is you create an AWS Lambda project. So this is not specific for Amazon Skills. It actually handles anything with Lambda, but because an Amazon Skill is a Lambda project, we can just utilize that. This is something that comes with the AWS toolkit, so it's a quick, start new project, deploys out. You have your code, you have your signatures and all that. You can just, you're ready, set, go. And then, like we talked before, we're going to get the Alexa.NET NuGet package, and that's going to handle our JSON parsing and generation. So really the only two things you have to handle when you're actually dealing with the skill service just to get something simple out there, and this assumes you've already done your interaction model design within the developer portal, is you have to handle skill requests and skill responses. So a skill request, that's what gets passed back from the Alexa service. So when I talk to Alexa, it sends the data up to the Alexa service, then it comes back and sends it to your Lambda function after that. And that's going through your stuff in the developer portal. It goes through your interaction model, makes sure everything's valid and everything's correct, feeds it back to your service. So at that point, you have any kind of data you need within the intents. You have the slots, you have the slot data. You can tell what type of request it is. So in addition to intents, which are things offered, given by the user that you define, there's also kind of pre-built requests as well, which would be like launch, stop. There's a couple other ones related to audio playback and video playback and stuff, but those ones we didn't really care about this time. And also, the skill request also contains the session user information that you need. So because we're going to be storing user sessions, we want to actually care about continuing a session beyond just the initial interaction point if they come back to it in the future. We need to get that data from the skill request itself so that we can do something with it, store it, utilize it, check to make sure devices are the same, all those pieces. So the skill request, you can do all these different things. The skill response is what you pass back to Alexa so it can continue the dialogue or end the dialogue or whatever else. So what it uses is, it's another JSON piece. And you can either pass it back plain text, which you just tell it to do something. You just say, you say whatever directly you want to tell the user, you just plainly type it out as plain text, send it back to them, and it will just read that back to them. There's also what's called SSML, just speech synthesis markup language. It's something that was defined actually a while ago in the past, and Alexa utilizes that for more complex speech. So if you wanted to sound something out, if you wanted to spell the letters in a word, you wanted to change its inflection on how it says something, all those pieces can be done in SSML. So it's kind of like just like an XML type format, but specific for speech itself. So there's plenty of documentation about that for whatever you want to do. Like I said, tell it to pause for 5 seconds, tell it to read out the numbers specifically in a word, any of those pieces. And then when you're building your skill response, not everything is straightforward. It's not always, I ask Alexa to do something and it tells me the answer back. It may ask me for more information. So when I talk to it, you can set these different things in the skill response. It'll actually tell it to reprompt the user, ask it for more information. You can end the session directly then if you want to, if it is the end of the session. So all those pieces have to kind of be taken care of as you're editing your skill response. But those are really the only basic pieces. If you want to make a super simple skill, all you do is you handle the request, see what it might want it to do, give them back a response, and that's it. Here's a small code sample. We'll again go into the code right after this. But this kind of shows here we have an intent coming in. We're doing just a simple if statement to see what the intent actually is, what the name of it is. And then if you look at the search intent, which is the last one on there in the if statement, that actually contains a variable, a slot with it. So we try to make sure the container itself was filled, and then we can look at the value in that, and we can go to our database, see what we need to do, and then send a response back to the user. And finally, once you've done all these pieces, once you've built your function out, made sure everything looks good, then you just simply deploy to AWS Lambda. So this is assuming you've already gone into the developer portal, change your configuration item, change your endpoints, make sure everything points to each other. You should be up and running. So all you need to do is a quick one-click deployment from Visual Studio to AWS Lambda. And like I said before, it gives you another way to test the interaction model. For the web service function using the JSON, you can feed it whatever data you want to. It'll give you results back. All that stuff's handled within Visual Studio. Or you can use the device itself. So assuming you've already registered it in the developer portal, as soon as you deploy it with AWS Lambda within Visual Studio, it's instantly available on your device itself. You can start talking to it. It is a little slow to start up. The initial interaction you do with it can be delayed by what I've seen so far is 5 to 10 seconds for a response, especially if you're doing a database call. But after that initial response, everything else is very quick. So you kind of have to give a little bit of time to process and update its functions and the web service pieces, but that's pretty much it. So now we're going to do a live demo here. So during this time, I'm actually going to turn on the audio, so if anybody wants to talk, they can, and you can tell me you haven't heard me this entire time or any of those pieces. Okay, so now I'm enabling audio, so if you guys want to say anything.
Hey Mark, this is Ryan. Hey, I have a quick question for you. Is the AWS toolkit in NuGet called AWS SDK.core? Is that the same thing?
No, you actually, it's an extension. It's not a NuGet package for that. When you get the extension, it pulls the NuGet packages into the project for you when you create it. The only one you have to specifically get off NuGet is the Alexa.net skill itself.
Okay, all right, because there is an AWS SDK.core. I thought that was kind of the same thing. I mean, maybe.
Well, that's the stuff you need for the actual coding pieces, and that's the libraries you need. But it doesn't give you those toolkit pieces that give you the extra windows on the left-hand side and the functionality. Those have to be Visual Studio extensions.
Gotcha. Okay, cool. Thanks.
Okay. So what are you guys, I have two windows open right now. Are you guys seeing the PowerPoint right now, or are you seeing a blue background?
Right now we're seeing PowerPoint. Your presentation, you're seeing the presenter screen.
Okay. All right, so I'm just going to do a quick run through of the different pieces that we talked about. Just to kind of show it, I'm not going to really do much functionality pieces in here. So this is your Amazon AWS portal. So within here, you have full access to anything within AWS. So what we want to specifically look at is Lambda. And then we can see here we have our endpoint. So this is the function I've published called Treasure House. And then normally, so if you were doing anything like Node.js, or if you were doing Python, you'd be able to actually code directly into this window, but we're using C#, so we have to actually deploy a package in here. But it gives you all your configuration items. You can set role, security. You have to actually set a trigger to be an Alexa skill, so that's one of the key pieces that it's a little bit lost in some of the documentation. What that does is it tells a Lambda function to expect Amazon skill input and output. It's a very simple thing to set up once you do it. You just have to remember to actually do that. So that's pretty much it from the Lambda side. When we look at the developer portal, so here you can see I've defined all the different skill types, languages. We showed this kind of screenshot before. And then we have our interaction model builder here. Sorry, logged me out there. So this, again, is where you define all of your kind of language back and forth for talking to your Alexa skill. So you can see I have these are my intents here. I have like end, enter, examine, information, leave, look. And if you think about something like Zork, these are your basic functionality pieces you'd want. And then, as we talked about before, you can do different utterances for it. So instead of just saying enter, you can say enter house, open door, go inside house, any of those different pieces you want to. And then when you're searching for something, maybe you would say open, explore, search, and you have to give the name of the container. And then if you look at our container definition, we are using a defined container slot. So this would be all the different containers we have within our applications. You'll also see these in the database itself, but you have to have nouns. You have to have something for it to know what you're talking about. You can't just say search car, because I don't have car defined in here, so car would never get past the web service because it wouldn't know what you're talking about. So you have to have defined every different piece of language you'd ever want to interact with it. And then we'll go into Visual Studio real quick. So this whole project is just one function right now. Don't look for code prettiness on this. It was more of just kind of a sample to get everything working. But the way this works, you have a skill request come in, and then as it comes in, you try to see what type it is. You want to say, okay, this is an intent. So I know I have an intent request. That means that Amazon has already taken the language that we've given it, parse it out, determine that as an intent that we've given it before, and then you can go through and see what kind of intent it is. So I have things like leave here defined, score, reset, all those different intents we already had. And there's some predefined ones you have to implement. Those would be like here we have a help intent, a cancel intent, a stop intent. Those are ones that Amazon forces you to define within your Alexa skill no matter what. They have to be in there or else you get some kind of error saying, you know, this intent is missing from your skill set. In addition to that, like I talked about before, there's some default functionality as well, which are like launch requests and end requests. And those are things you have to handle so that you can know when the session first starts and the session ends. And then, so I will show, we'll listen to the skill now, we'll actually try it out. And it's currently published on there, and we'll make one small change to it, and then we'll see, I'll show you a quick way of how you publish it and how everything works. So, Alexa, treasure house. I take a second to start up just because the web service hasn't been activated yet. Alexa, treasure house.
Welcome to the treasure house. You are outside an old weathered house with one other person. What would you like to do?
Enter house.
You entered the house. You are now inside a dimly lit room with other people. What would you like to do?
Look around.
You look around the room and currently see a desk, a couch, a table, a lockbox, a cabinet, and a fireplace.
Search couch.
You search a worn-out leather couch and see a coin.
Examine coin.
After examination, it looks like the coin is an ordinary, unremarkable silver dollar.
Take coin.
You took the coin.
Search couch.
You searched a worn-out leather couch, but it was empty.
You can see here that we've had the actual skill. We're talking the skill is responding. We're going through different state pieces, and we successfully had it actually update the state of things. So we looked inside the couch, we found a coin, we took the coin, we tried the couch again, now the couch is empty. So these are all things that are stored inside the database, updating states in real time for different users. And then...
You searched a worn-out leather couch, but it was empty.
Close.
There was a problem with the requested skills response.
So that's if you don't have something defined that'll tell you there's a problem with the response. But what I want to do is end the session so I can come back into the session and see what's, just to make sure it's the state of everything. Alexa, treasure house.
Welcome to the treasure house. You are currently inside a dimly lit room with two other people. What would you like to do?
So you can see here it actually says I'm already inside the house now, so it's saved the state, it knows what's going on. Now, so one last thing we'll do for the demo is that I'm going to do a quick update of the skill itself, so we can see. Let's say we want to add a status function. We want to add something that knows what I have in my inventory or how much I weigh or how much weight I'm carrying currently. So can you guys still see my screen?
Yep.
Okay. So in here, I've already added this function. I disabled it right now. So Alexa, treasure house.
How's it going? Good.
What would you like? Here's your flash briefing.
So currently, there's no status defining. So now we're going to define the status intent. So I'm going to uncomment out this code, and then this is going to go into the database. It looks at to see what I have in my current session, what I'm currently holding, and returns that text back to the user. So we're going to publish this out. So all we do is a simple right-click, publish AWS Lambda. And then everything's already set here. And one thing about Alexa skills, they have to be deployed on the US East and Northern Virginia server. They are not supported anywhere else at all. So you have to use that server. That's actually another kind of gotcha when you're dealing with this stuff, is you have to make sure you're in that region with your AWS. So we're going to let that upload the code. Should just take a second. The same time, we're going to go in here. We're going to define that status skill or status intent. So all we're going to do here is go down to the intent piece. We're going to add one, and we're going to add S. It's our intent. We're going to give it a sample argument, so it can also be status or inventory. So at that point, anytime we say the words inventory or status, it's going to go back to that intent and hit the code piece for us. So lastly, we just need to save it off and then build the model out. And this is going to do our publishing into the Alexa developer portal and then transfer it onto the device. There's probably maybe about a 30-second delay or so. Anybody have any questions so far while we're waiting for this thing to update?
That's cool, though. I remember Zelda.
What happens if you have multiple utterances that are the same?
It won't let you. So it actually blocks you within this piece, within the utterance builder. If you do anything that uses the exact same word as something else, it'll just tell you it's an error.
How does it know when it's used under different contexts?
You can use a word can be used in other places. Like if you were to say car versus build car, that's okay. But you could not use the word car in multiple pieces. You could not use that in two different intents by itself. So phrases are okay that differ slightly, but not exact words or exact phrases.
So the multiple users, it's each person interacting with a different device, or is it multiple people on one device?
It's multiple people on different devices. So each device is purely tracked by a device ID and a user ID, which be coming from kind of your Amazon account. It doesn't know anything about you specifically unless you give it permissions to be able to allow that stuff. But all we need in this kind of case is just knowing your device ID itself, and then we can handle all the pieces we need to for that.
So how does it handle like a race condition where two people ask to take the same resource?
It's not complex enough for that right now, because this is just a simple demo, so it's not really handling any kind of like lock conditions or any of that. It's kind of the first person to get it and put it in their inventory would win.
Okay. So does so then it would warn you if you tried to take something that wasn't there, or?
It would just tell you it doesn't exist anymore. So if you tried to pick up a fork that had already been taken, it would just say fork not found. Okay, so now we'll test out our new piece that we just added. Alexa, treasure house. We may run into that same issue where it's going to not load the first time. For some reason, the echo shows worse about that. Alexa, treasure house.
Welcome to the treasure house. You are currently inside a dimly lit room with 2 other people. What would you like to do?
Status.
Could not understand your request. Please try again. Status.
Status.
Could not understand your request. Please try again. Status.
Inventory.
Could not understand your request. Please try again. Status.
So it looks like something didn't get uploaded in here.
Sorry,
So
I don't know that.
that starts arguing with you. So I'll just do another quick code upload just real quick to make sure that sometimes if you don't have the model built before the code comes up, it will not update it properly.
Hey, Mark, your function.cs is not saved.
Oh, yeah. I'm used to the Mac where it auto-saves that stuff. Okay, thanks, Ryan. Okay.
Kind of crazy for all that it is. It's really just an easy hook into a text-to-speech and speech-to-text. That's really all it provides. Yeah. Because I had built something similar where it used, rather than constantly reaching out. So Google has a free actual API to for speech-to-text, and I just used one on a machine. Would search for the activation device. So Google wasn't constantly, you didn't have Google constantly pinging, you would have
Alexa
for an activation.
treasure house.
At which point it would send the command over to the Google API, do an interpretation.
You are currently inside a dimly lit room with 2 other people. What would you like to do?
Got it. Times and stuff to you. And then it's
You are
like,
currently holding 1 item with a total weight of 0. You have 10 action points remaining.
that's not
Inventory.
You are currently holding 1 item with a total weight of 0. You have 10 action points remaining. Your game is complete. Your score for this round is $1. Please play again.
All right, so you can see there that we did finally get our piece updated, so we were able to ask it the status, and it was able to give us the piece back based on our change to the Lambda function and the developer API. And that is it for the presentation now. Does anyone have any questions?
That's cool.
so how long did it take you? Like, I mean, obviously getting a lot of the infrastructure is takes time, and that's a pain. But outside of that, like actually just once you had everything sorted out, how long did it take you to get it all set up?
Once all the infrastructure stuff was in place, and that took about probably 2 days to get all those pieces up and running, I pretty much just spent all day yesterday coding this. That includes the whole database architecture, adding in all these different variable items. So all those pieces, and I'll actually show that real quick, they're all stored off in our Amazon RDS instance. You can see here we have all of our containers defined with descriptions so it knows what to read to you. It contains the session information. It contains items you've picked up yourself, all the different various items that are involved in the game. So that was actually a big chunk. That was probably half of it right there, was just architecting the database out into a correct structure. And then the logic associated with kind of the back and forth pieces for moving you around, maintaining your state, all those were probably the other half of the day. So this is about a day's worth of work. If I wanted to complete it and make this usable in a real fashion, probably another 3 or 4 days to get this up and usable as like a actual published skill.
So basically, the next step is you just get a parse Zork down and just create it this way, right?
Yeah, somebody's actually done that before. There actually is an Amazon skill for Zork itself.
Huh, I was just about to ask if somebody done that.
So the way this is set up, the database running in the background is set up for this specific skill. So that means anyone who installs this setup is working off of the same instance?
Correct. So you don't actually install the skill itself. Nothing related to the skill actually goes on your device. You enable it, and when it's enabled, it gives you access to be able to call the web service out and do this stuff, but nothing actually gets stored locally.
Okay.
And so that's one of the reasons why like having a database backend allows multiple users to be into it, because then anyone's device is pointing to this instance, we update the same database, we update the same code in the backend. Everyone's
So if you wanted it per user, you need to be tracking the individual device and its progress.
Yeah, and that's what we do here within like our user table here. You can see there we have different device IDs coming in with different user accounts and high scores and all that.
How do you hook up your Alexa to this? Is it just based on your account?
Yeah.
I can't find just
Hey.
basic.
How was it?
Yeah, so you have to go to the developer portal and then
What you guys about?
can you hear me?
Yeah.
Oh, really?
Yeah, so you have to go to the developer portal
Classes and homework and stuff like that?
and then add your
What
device.
did I say?
I can hear Chris talking.
You.
So yeah, as long as you're enabled in your portal, but I can't distribute this to somebody else's account right now without activating them on my developer portal until I get it approved.
Got it.
How long does it usually take to get approved, Mark? Do you have any idea?
I'm not sure. I didn't officially publish it, but I'm not sure how stringent they are with the actual approval process. But I don't think it's anything like Apple's, where it's
Yeah, I'm
Yeah.
kind of wondering Apple versus this, what it would be like.
Apple versus
Well,
Google.
also probably not right now because they're just trying to get people on it. You restrict it more as you get farther along.
yeah. And then so right now there's also no way to monetize an Alexa skill. Just so you know, you can't charge for them. And they're experimenting right now with advertising to where if you start the skill up, then it may say like, oh, well, listen to this 10-second ad, and then we'll start the skill for you. But it's not officially implemented yet. So there's really, you kind of just make them for free for people to use at this point.
Well, I mean, there's the monetization I thought of if you can buy goods and services through it. Like I thought Domino's, you could order pizza through it or something.
Exactly. You can monetize products within it, but you can't monetize. It's not like an app where you can say, I want to charge you $2 to download my game.
Okay.
Any other questions?
So do you, on your Alexa app, do you actually, I mean, do you have a credit card that's associated with your account? How do you do those purchases? Because I've never used Alexa.
Yeah, it has to be, so everything's through your Amazon account, so you can't really have an Alexa without any kind of Amazon account at all. So as soon as you're wired up with that, it already knows what your device is linked to. So as soon as you say like, order toilet paper, it already knows you're on your own account. It knows your Amazon account.
It goes to your Amazon account, uses your credit card, and that's how it does. Okay.
Yeah.
It's like Amazon trying to like further integrate.
I'll just order toilet paper while I'm saying that to you too.
Thanks, Mark.
That was good.
Great.
Yeah, that's cool.
All right, if there's no other questions, I will end the session then.
Thank you.